CI or cast iron pipes and PVC or polyvinyl chloride pipes, all with different diameters and different sizes. By the end of this lesson, you will be able to cut MS pipes of various diameters in different angles, cut GI pipes of various diameters and sizes, cut CI pipes of various diameters and sizes, and cut all kinds of PVC pipes of various diameters and sizes. The required tools and materials for this are bench vise 1, pipe vise 1, flat file 1, hacksaw frame and blade 1, tri-square 1, steel rule 1, scriber 1, cold flat chisel 1, hammer 1, pipe cutter 1, pencil 1, 50 mm PVC pipes, 4-inch cast iron pipes, 50 mm MS pipe and GI pipe 1.5 inches. Let us start with cutting different diameters of MS pipes in different angles. For this, we will learn to draw the development of a 90-degree T-branch, cut and prepare the pipes as per dimensions, set a 90-degree angle of the branch pipe using the tri-square, ensure the correct size of pipes are used. Prepare the development for a 90-degree branch on a drawing sheet. Cut and paste it on the pipes. Punch mark the profile of the development of both pipes. Cut the branch pipe along the punched mark profile and file it. Now, let us look at welding a pipe on a 45-degree angle joint on an MS pipe of 50 mm and 3 mm wall thickness by preparing the development of the pipe for a 45-degree branch joint. For the development of a 45-degree branch pipe, draw a center line AB. Mark the points C, D, E and F, taking the radius and the length of the given pipe using the center line AB as reference. On the line CD, locate the position of the 45-degree branch pipe. This will be G. Draw a 45-degree angle at the point G. Choose a suitable height and mark the height of the branch pipe in a 45-degree line from the point G. From I, draw a horizontal line on both sides, x dash. This x dash will be the baseline for the drawing development. From I, now plot the outside diameter of the branch pipe IJ on the line x dash. Draw a center line for the branch pipe. This line will cut the main pipe's center line AB at K. Join GK. Draw a perpendicular line to GK at K which meets CD at H. Join KH. Now IGKHJ will be the shape of the branch pipe. Draw a semicircle equal to the branch pipe outside diameter. Divide the semicircle into 6 equal parts as 0, 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5 and 5 to 6. Draw vertical lines from these points 1, 2, 3, 4 and 5. Already there will be 2 vertical lines IG from the point 6 and JH from point 0. These vertical lines will cut the branch pipe lines GK and KH at points 6 dash, 5 dash, 4 dash, 3 dash, 2 dash, 1 dash and 0 dash. Note the points 6 dash and G as well as points O dash and H are the same points. In the baseline XX dash, plot 13 points equal to the distance of 0 to 1 as 0, 1, 2, 3, 4, 5, 6, 5, 4, 3, 2, 1 and 0. Draw vertical lines to XX dash from these 13 points. Draw horizontal lines parallel to XX dash from points 6 dash, 5 dash, 4 dash, 3 dash, 2 dash, 1 dash and 0 dash. These 7 horizontal lines will cut the 13 vertical lines from the baseline at 13 points. Join the 13 cutting points with a regular smooth curve. Now, the required development for the 45-degree branch pipe will be ready. Give an allowance of 3 to 5 mm at the edges of the development. For developing a hole in the base pipe, above the main pipe draw 7 lines parallel to AB, namely 3, 2, 1, 0, 1, 2 and 3, equal to the distance of 0 to 1 on the semicircle. Draw vertical lines from 0 dash, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash and 6 dash. These vertical lines will intercept the 7 horizontal lines. Join the intercepting points with a smooth curve. The required development for hole is now ready. Firstly, in order to hold a pipe in the pipe vise, we need to clean and check the vise for its functioning. Adjust the movable jaw of the pipe vise to suit the pipe. Rest the pipe on the fixed jaw, keeping the part to cut close to the jaw and then tightening the pipe using the movable jaw. Measure the length as per the drawing. Wrap a sheet of rectangular paper at marked places around the pipe. Bring the edges of the pipe together. Mark around the edge of paper using a pencil. Cutting the GI pipe. Make a small V groove on the cutting line with the help of a knife edge file. Fix the fine tooth blade in the hacksaw and hold the hacksaw handle with the right hand and the hacksaw frame with the left hand. Move the blade to and fro on the marked groove at a 40 to 50 stroke per minute for the full length of the blade. Ensure to use a coolant while cutting. In order to cut large diameter pipes, rotate the pipe after cutting till half the depth and repeat the procedure. If using a pipe cutter to cut the pipe, then fix the pipe in the pipe cutter. Rotate the handle to adjust the cutter till 3 wheels are in contact with the pipe. Rotate the pipe cutter around the pipe. Check whether the cutting wheel is sitting exactly on the scribed line after 1 or 2 turns. Put extra pressure on the cutting wheel after this. Continue this procedure. Support the pipe with the free hand to prevent the pipe from falling. Continue this procedure until the pipe is cut. Check the squareness of the end using a tri-square. File the square by using a half round file. Check the condition of the cutter. Then clean it thoroughly. Our next step will be to learn to cut a cast iron or CI pipe of different diameters and sizes. Measure the length of the pipe required and make a mark around the pipe where the cut has to be made. Then place the pipe over the wooden V-block and cut the pipe along the mark. Tap the end of the pipe after 3 or 4 cuts around the pipe. In case the pipe does not break, rotate the pipe, repeating the cutting and tapping until the pipe is cut. File the edge of the pipe with a flat file. Lastly, let us look at cutting PVC pipes of different diameters and sizes. Hold the PVC pipe on the pipe vise firmly and mark the required lengths as per the drawing. Step cut PVC pipe for depths of 5, 10, 15, 20, 25, 30, 35, 40, 45 and 50 mm. Fix fine tool's blade in the hacksaw. Hold the hacksaw in the right hand and its frame in the left hand. Move the blade to and fro on the mark and use 40 strokes per minute for the full length of the blade. File the edges with a flat file. Check the level using a tri-square. In this lesson, we have learnt to cut MS pipes of various diameters in different angles, cut GI pipes of various diameters and sizes, cut CI pipes of various diameters and sizes, and cut all kinds of PVC pipes of various diameters and sizes. Hope you have a clear understanding of this session. Thank you all and see you in the next video. Hello everyone and welcome to this module on the plumbing trade. In today's video, we will learn about the various pipe fittings and assemblies as per the given layout and join pipes of the same diameter as well as pipes of different diameters by the process of gas welding. By the end of this lesson, you will be able to study the drawing of the pipeline circuit and demonstrate the hand tools used, Make a pipeline circuit by identifying its classes, joining GI fittings with the GI pipes. Create a simple pipeline connection and fix the GI pipes with the fittings. Cut and bevel the pipes for welding. Tack the pipes for butt welding. Make a root run and clean it for pipes with the same diameter. Develop the pattern for a 90-degree T. Cut, prepare, check and clean the pipes, and tack the pipes and check the angle and joint of welding for pipes with different diameters. The following are the required tools and equipment for this lesson. Steel measuring tape 1, marker or pencil 1, pipe vise 1, hacksaw frame with blade 1, flat file 1, BSP die stock and dies 1, oil can 1, double end spanner 1, adjustable wrench 1, water pump plier 1, pipe wrench 1, GI pipe bits as required, GI elbow as required, GI T as required, GI cross as required, GI coupling as required, GI pipe nipple as required, GI hex nipple as required, GI reducer coupling as required, GI cap as required, GI plug as required, globe valve gunmetal as required, cotton waste as required, and lubrication oil as required. Let us make a pipeline circuit on a GI pipe by identifying different classes of GI pipes and GI fittings and understand the GI pipe BSP threading. Select the appropriate hand tools and materials according to the drawing. Hold the GI pipe in the pipe vise and cut the bits to the required size with the hacksaw frame blade. File the edges with a flat file and remove the burrs. Select BSP or British Standard pipe threads on the GI pipe bits using the BSP die stock and dies. Lastly, let us look at the steps involved in a simple pipeline connection by fixing the GI pipes with fittings as per the drawing. Calculate the length of the pipes required based on the drawing. Cut the pipes as per the calculated length using a pipe cutter or a hacksaw. Cut the thread at the end of the pipe using a die stock. Assemble the pipe with standard fittings. Now, we will assemble the pipe and the pipe fittings and then fix the fittings on the pipe. Hold pipe 1 in a pipe vise. Wind the hemp packing or cotton thread material on the external threads of the pipe. Apply sealing compound over the pipe threads and adjust the pipe wrench to suit the pipe or pipe fittings. Continue the screwing process till full threads are inside. Fit T1 to the pipe 1 using a pipe wrench. Fit pipe 2 to T1 using a pipe wrench. Fit T2 to pipe 2 using a pipe wrench. Fit pipe 3 to T2 using a pipe wrench. Fit elbow to pipe 3 using a pipe wrench. Fit pipe 4 to the elbow using a pipe wrench. Fit a socket to pipe 4 using the pipe wrench. Fit the bit cock to the socket using a pipe wrench. Fit pipe 5 to T2 using a pipe wrench. Fit the socket to pipe 5 using a pipe wrench. Fit the bend to the socket using a pipe wrench. Fit the socket to the bench using a pipe wrench. Fit pipe 6 to the socket using a pipe wrench. Fit T3 to pipe 6 using a pipe wrench. Fit pipe 7 and 8 to the T using a pipe wrench. Fit the socket to pipe 7 and 8 using a pipe wrench. Fit the bit cock to the sockets using a pipe wrench. Remove any excess hemp, string or sealing tape after completing the joints using a hacksaw blade or a blow lamp. Let us first look at joining pipes that have the same diameter. Cut the pipes to 75 mm length using a hacksaw and file its end square. Set the two pipes on an angle or channel fixture to form a coaxial pipe butt joint with proper root cap. Follow necessary safety precautions. Tack weld in 3 places, keeping 1.5 mm root cap between the pipes. Divide the pipe circumference into 4 segments. Keep the pipe horizontally on the fixture. Deposit the root run starting from the 3 o'clock position to 12 o'clock position using proper blowpipe and filler rod angles. Turn the pipe joint into the clockwise direction so that the end of the root run already made in the previous segment comes to the 3 o'clock position. Continue to weld the root run for a second quarter segment as done for the first segment. Similarly, complete the root run of the third and fourth segments. Ensure root penetration by maintaining a keyhole at the root throughout the root run. Let us now learn to join pipes with different diameters. Develop and lay out the pattern for the 90-degree T pipes with a cutout on the main pipe by parallel line development. Cut, form and lock groove the joints of the pipe as per the job drawing. Check, set and align the 2 pipes as per the job drawing. Tack the joint by gas welding and check for perpendicularity using a tri-square. By the end of this lesson, you will be able to study the drawing of the pipeline circuit and demonstrate the hand tools used. Make a pipeline circuit by identifying its classes, joining GI fittings with the GI pipes. Create a simple pipeline connection and fix the GI pipes with the fittings. Cut and bevel the pipes for welding. Tack the pipes for butt welding. Make a root run and clean it for pipes with the same diameter. Develop the pattern for a 90-degree T. Cut, prepare, check and clean the pipes. And tack the pipes and check the angle and joint of welding for pipes with different diameters. Hope you have a clear understanding of this session. Thank you all and see you in the next video. Hello everyone and welcome to this module on the plumbing trade. In today's video, we will practice using various hand tools like measuring tools, cutting tools, wrenches, die sets, screwdrivers and washers while understanding their importance and learning to maintain them. By the end of this video, you will be able to place the measuring tools in the workpiece and measure the required length. Use cutting tools efficiently. Use an adjustable wrench, water pump plier and pipe wrench. Use a ratchet die set for cutting external threads of pipes. Use a screwdriver, washer and spanner. Understand the importance of plumber hand tools and their application, and understand how to maintain plumber hand tools. Let us collect the tools and equipment required to do this. Steel rule 1, steel tape 1, 4-fold box wooden rule 1, trowel jumper 1, water pump plier 1, adjustable wrench 1, pipe wrench 1, hacksaw frame and blade 1, ratchet die set 1, screwdrivers, washers as required, and spanners. How to use measuring tools. Steel rule. Ensure that the steel rule is kept straight across the object to be measured. Place the steel rule on the workpiece and measure the given dimension. Mark the required length. Do not use the steel rule as a scraper, screwdriver, or pry bar. Steel tape. Gently pull the tape from its case, guiding it from the starting point to the desired length. Measure according to the given dimensions. Mark the measured portion. Some safety points to remember. Wipe down the tape after each use with a clean, lint-free cloth. Be cautious when working around electrical appliances. Retract the tape slowly. The folding rule is handy for measuring both shorter and longer distances. If you need to measure something small, just unfold one section of the ruler. Place the 4-fold box wooden rule to measure the given dimension on the workpiece. Mark the measured portion. Folding rules work well when you need to measure something that is high or further away. You can bend the ruler into a triangle or at some other angle and use it to approximate the angle on a house or a bridge. The folding rule can be also folded into a 4 shape to assist with drawing parallel lines. Be cautious of the ruler's sharp edges. Handle it carefully to avoid cuts. Using a rowel jumper. Hold the rowel jumper at the required angle. Place it on the marked area to make a hole in the wall or concrete. Strike with a hammer on top of the rowel jumper. Rotate the rowel jumper frequently. Make a hole to the required depth. Some safety points to remember. Always wear safety glasses or goggles to protect your eyes from debris. Use gloves to prevent cuts and abrasions while handling the tool. How to use a water pump plier. Hold the workpiece with jaws. Use a firm grip on the water pump pliers with the smooth jaws against the object for tightening and the teeth against the object for loosening. Work with round objects like spindles. Some safety points to remember. Hold the pliers using a firm grip, keeping your fingers away from the jaws. Avoid placing your hand directly in the path of the jaws to prevent pinching. How to use an adjustable wrench. Place the adjustable wrench on the stuffing box of the bibcock. Grip and work to tighten or loosen the nut. Use it to dismantle the hand pump parts. Use it to assemble flange bolt and nuts on the suction pipe. Some safety points to remember. Never strike the wrench with a hammer or another tool. Striking it can break the wrench and cause injury. How to use a pipe wrench. Place the pipe wrench on round objects or pipes and fittings. Grip well and work to dismantle or assemble the pipe with fittings. Use the correct size pipe wrench according to the size of the pipe or fittings. Protect your eyes by wearing safety glasses or goggles. Pipe wrenches can cause eye injuries if they slip and strike the eye. How to use a hacksaw frame and blade. Use a hacksaw for cutting flats and pipes. Use a fixed hacksaw for a fixed length and an adjustable hacksaw for different lengths. Use deep cutting for cutting bigger diameter pipes and tubes. Select the correct pitch blades according to the cutting workpiece. Before using, check the blade for any signs of damage or wear. A damaged blade can compromise safety and efficiency. If the blade is worn out, replace it with a new one. How to use a ratchet die set. Select the die according to the size of the pipe. Place the dies in the die stock. Place the die set on the pipe end and hold firmly in the pipe vise. Rotate in clockwise direction to cut external threads on the pipe end. Reverse the action by changing the gear of the ratchet die stock. Check the threads using female threaded fittings. Use lubricant oil frequently while cutting threads. Some safety points to remember. If the die gets stuck or encounters resistance, reverse the the ratchet slightly to release it. Forcing it can damage the threads or the tool. Protect your eyes with safety glasses or goggles. Metal shavings or debris can fly during threading. How to use screwdrivers. Use the appropriate screwdriver bit to drive screws into the brick wall. Use a ratchet for quick and easy screwing operation. Use a reversible screwdriver that has a star head and a flathead screw. Never hammer the screwdriver handle as it can damage the handle and affect its usability. For electric work, use a screwdriver with an insulated handle to safeguard from an electric shock. How to use washers. Place the washers in between the bolt and nut for tightening the flanges. Place the washers for various locking operations of two metal objects. Ensure that the washer fits snugly around the bolt or screw. The inner diameter should be slightly larger than the fixing diameter. If it is too big or too small, it can affect its effectiveness. How to use spanners. Select the correct size of the spanner for locking nuts. Use a single end for a specific purpose. Use a double end spanner to tighten two different sizes of nuts. Use a ring end for firm grip while tightening bolts and nuts where there is obstruction and a long handle is needed. Avoid pushing a spanner. They are designed for creating torque and not pushing. Pushing a wrench can break it, so always turn it instead of pushing. Care and maintenance methods for the common plumber's hand tools. Steel tape. The end of the steel tape should never be folded or bent. After being used, the tape should be wiped dry. Roll jumper. It should be rotated frequently while striking. It should be taken out in frequent intervals to remove any material that is stuck to it. Hacksaw frame with blade. After each use, clean thoroughly to remove any debris. Flat file. It should not be used as a striking tool. After being used, remove the chips. Chisel cold flat. Do not use a mushroom-headed chisel. While using chisels horizontally, do not strike with a hammer. Screwdriver. It should be used to fix the tip correctly to the head of the screw. It should not be used as a chisel. Water pump plier. It should not be used for heavy gripping and tightening. Adjustable wrench. Do not strike the handle portion with a hammer while handling heavy work. Pipe wrench. Do not use as hammer. Lever should be avoided. Use correct size according to the size of the pipe. Spirit level. Do not throw after using. Ball peen hammer. Do not use without a wedge. Do not throw from a height. Double-ended spanner. Do not use for striking and do not use with a lever. Trowel. Do not use without a ferrule. Do not use a cracked or bent trowel. Die stock with dies. Do not give more depth to cut quickly and should use lubrication oil frequently. Pipe vise. Do not over-tight the handle. Do not use the lever to over-tight the handle. In this video, we have discussed placing the measuring tools in the workpiece and measuring the required length, using cutting tools efficiently, using an adjustable wrench, water pump plier and pipe wrench, using a ratchet die set for cutting external threads of pipes, using a screwdriver, washer and spanner, understanding the importance of plumber hand tools and their application, and understanding how to maintain plumber hand tools. Hope you have a clear understanding of this. Thank you all and see you in the next video. Hello everyone and welcome to this module on the plumbing trade. In today's video, we will explore pipe bending techniques for both GI pipes and PVC pipes with a diameter of up to 50 mm. By the end of this video, you will be able to bend a GI pipe using the hot method, bend a GI pipe using the cold method and a pipe bending machine, bend a GI pipe using a portable hand-operated bender, bend a GI pipe using a hydraulic bending machine, bend a PVC pipe using dry sand, bend a PVC pipe using heat, and bend a PVC pipe using a heat fan and bend spring. Let us collect the tools and equipment required to do this. Steel rule 1, steel tape 1, cold flat chisel 1, ball peen hammer 1, hacksaw frame with blade 1, wedge template 1, marker 1, tri-square 1, soft hammer 1, safety glasses, a respirator, heat resistant gloves, steel wool as required, sandpaper as required, bend spring 25 mm as required, pipe bending machine 1, portable bending machine 1, hydraulic bending machine with all the accessories 1, template as required, PVC pipe cutter 1, bench vise 1, blow lamp 1, flat file 1, cotton vase as required, wooden plug as required, GI pipe 12 mm to 75 mm as required, PVC pipe 12 mm to 75 mm as required, dry fine silica sand as required, hydraulic oil as required, heat gun as required, PVC pipe bending heaters as required. Let us first bend a GI pipe using the hot method. Start by filling the pipe ends square. Then remove the burrs. Calculate the length of the pipe as follows. If D is the diameter of the bend and phi is the angle of bend, L is the length of curved portion, then L equal to 360 into pi into D into phi, where OA is the inner radius of the bend represented by capital R, AB is the radius of the pipe represented by lowercase r, then OB is the radius of the bend, which is capital R plus lowercase r. L is equal to capital R plus lowercase r into 0.1745 into 5. The total length of the pipe will now be L1 plus L2 plus L. Measure and mark off the pipe at the center of the bend and at the beginning and end of the bend from the center line. Measure the inside diameter of the pipe and select two suitable wooden plugs for the pipe. Plug one end of the pipe with a wooden peg. Fill the pipe with clean, dry and fine sand. Compress the sand by tapping the pipe with a soft hammer and plug the other end. Clamp one end of the pipe in a vise and protect the clamped portion of the pipe with lead or copper shims. Heat the area to be bent using an oxyacetylene torch until it glows red. Pull down the pipe gently in the direction of the bend. Take short pulls until the correct bend angle is reached. Check the bend radius with a template. Apply heat throughout the whole operation and overbend slightly and straighten out the final bend. Remove one end of the plug. Remove the sand by tapping the pipe gently with a hammer. Now, we will use a cold method to bend a GI pipe using a pipe bending machine. Check the pipe for squareness and ensure it is free from burrs. Measure and mark off the center of the bend. Mark off the beginning and the end of the bend from the center line. Select the appropriate former to suit the size of the pipe. Clamp the bending machine in a bench vise. Keep the former in position and lock with a pin. Fix the backstop with a pin. Place the pipe in the bending machine, passing it through the bending arm and ensuring that it is seated with the groove of the former and against the backstop. Set the roller on the bending arm by adjusting the screw and lock nut. Bend the pipe by pulling the bending arm towards your body. Check the angle and radius of the bend using templates. Let us bend a GI pipe using a portable hand-operated bender. Check the pipe for squareness and ensure it is free from burrs. Measure and mark off the center of the bend. Mark off the beginning and the end of the bend from the center line. Prepare the pipe bender for bending the pipe, grouting the machine and ensuring that it is properly balanced while bending. Select the pipe for the pipe bender. Check the bender for all its components. Insert the pipe with a suitable former. Push off the leverage handle and give gradual load to the machine. Bend the pipe to the required angle. Check the bent pipe. Check the angle and radius of the bend using templates. Now let us use a hydraulic bending machine to bend the pipe. Arrange the size of the former, both inner and back. Set the former. Open the pressure release valve. Insert the inner former. Set the pipe in the proper location. Close the base plate on the proper hole. Close the pressure release valve. Pull and push the operating lever. Providing pressure to the pipe will allow it to bend. The inner formers are interchangeable and can bend pipes up to 75 mm in diameter. the inner former, back former, hydraulic ram, pressure release valve, operating lever, bleed screw and base plate. Stop the pull and push by using the operating lever. To achieve the required angle of bend, repeat the process of pull and push. Now, we will learn to bend a PVC pipe using the dry sand method. Cover one end of the pipe with a cap. Use hot sand to fill the pipe and bend it without it collapsing. For that, pour the sand into a dish and put it in an oven. Fill the pipe with sand so that it is a few inches past the bend block of one end. Heat the sand to 425 degrees Fahrenheit or 281.3 degrees Celsius. Carefully pour the hot sand back into the PVC pipe. Slowly bend the pipe into your desired shape. Empty the sand out and let the pipe cool. Bending a PVC pipe using a hair dryer. Fill the pipe with enough sand to cover 2 or 3 inches above the planned area. Apply heat evenly around the planned bend. Slowly bend the pipe, applying more heat as necessary. Remove the sand and let the pipe cool. Bending a PVC pipe using a heat gun and bend spring. Take a 25 mm PVC pipe and bend spring. Insert the bend spring into the pipe. Apply the heat evenly around your planned bend. Slowly bend the pipe to the planned shape. Bending procedures must be conducted in a well-ventilated area. Always use protective clothing. Use safety glasses. Do not expose the pipe to open flames or excessive temperature. In this video, we have discussed how to bend a GI pipe using the hot method, bend a GI pipe using the cold method in a pipe bending machine, bend a GI pipe using a portable hand-operated bender, bend a pipe using a hydraulic bending machine, bend a PVC pipe using dry sand, bend a PVC pipe using heat, bend a PVC pipe using a heat fan and bend spring. Hope you have a clear understanding of this. Thank you all and see you in the next video. Hello everyone and welcome to this module on the plumbing trade. In today's video, we will learn to assemble GI pipes with standard fittings. Additionally, we will explore various water distribution systems and explain how to connect pipelines to buildings according to drawings. By the end of this video, you will be able to fix elbows with the GI pipe, fix the union with the GI pipe, fix valves with the GI pipe, assemble the GI pipe with standard fittings, understand the water supply system from the source to the overhead tank, and understand the pressurized water distribution system. Let us collect the tools and equipment required to do this. GI plain coupling as required, GI ribbed coupling as required, GI T as required, GI elbow as required, GI 4-way as required, GI 100 mm, 150 mm barrel nipple as required, GI reducer coupling as required, brass bibcock as required, GM wheel valve as required, hexagonal nipple as required, gate valve as required, rubber washer as required, GI pipes as required, steel tape 1, rowel jumper 1, hacksaw frame with blade 1, pipe vise 1, pipe wrench 1, ratchet die set 1, screwdriver 1, cutting plier 1, hemp packing as required and a ball peen hammer 1. Let us start with the procedure. Join pipe number 2 with the 4-way cross. Fit pipe number 3 with the cross. Join the plain coupling to the other end of the pipe number 3. Assemble the GI bend to the plain coupling. Fit the ribbed coupling to the other end of the bend. Join pipe number 4 to the ribbed coupling. Fit T with pipe number 4. Join pipe number 5 to the opposite end of T. Assemble elbow with pipe number 5. Fit pipe number 6 to the other end of the elbow. Join T with pipe number 6. Fit pipe number 1 with the opposite end of T. Join pipe number 1 and 2 with a union. Fit a 150 mm barrel nipple to the left side of the cross and place a cap for it. Put another 100 mm barrel nipple to the right side of the cross. Join the reducer to the barrel nipple. Assemble the bib cock to the other end of the reducer. Fit a 100 mm barrel nipple to the bottom T. Assemble the globe valve to the nipple. Place the hexagonal nipple to the left side of T. Assemble the gate valve to the nipple. Assemble GI pipes with standard fittings. Hold pipe number 2 in a pipe vise. Wind the hemp packing or cotton thread material on the external threads of the pipe. Apply sealing compound over the pipe threads. Fit the 4-way cross to pipe number 2 and tighten it using a pipe wrench. Wind the hemp packing to the external threads of all the pipes and standard fittings and apply sealing compound over the threads before joining with the other one. Fit pipe number 3 with the cross. Join the plain coupling to the other end of pipe number 3. Fit the GI bend to the plain coupling. Assemble the ribbed coupling to the other end of the GI bend. Connect pipe number 4 to the nibbed coupling. Fit T with pipe number 4. Connect pipe number 5 to the opposite end of T. Assemble the elbow with pipe number 5. Fit pipe number 6 with the other end of the elbow. Connect T with pipe number 6. Fit pipe number 1 to the opposite end of T. Fit the rubber washer into the union. Set pipe numbers 1 and 2 with the union. Hold one side of the union in one pipe wrench and the ring of the union in the other. Turn the two pipe wrenches gently in opposite directions and assemble. Use grease or Vaseline on the union joint for easy disconnection. Fit a 150 mm barrel nipple to the left side of the cross and place a cap for it. Join another 150 mm barrel nipple to the right side of the cross. Assemble a bib cock on the other end of the reducer. Fit a 100 mm barrel nipple to the bottom side of T. Assemble the gate valve to the 100 mm barrel nipple. Allow a clearance between the valve and pipe. Join a hexagonal nipple to the left side T. Assemble a globe valve to the hexagonal nipple. Test the joints for leakage. Plug all the openings in the section of test line with pipe nipples, socket and plug. Pump the water into the pipeline completely without any air pocket. Continue the process till the pressure gauge shows steady reading. Keep it under the required pressure. Observe for any leakage in the joints and pipes. Rectify the leaking joints and pipes. Repeat the test till the pressure is maintained for 3 or 4 hours. Understanding the water supply system from the source to the overhead tank through gravity as per drawing. An overhead tank is a large container typically made of steel, concrete or plastic positioned at an elevated location like a rooftop. The water source. This can be a municipal water supply, a well or any other source located at a lower elevation from the tank. These connect the water source to the pipe and then distribute water from the tank to various outlets throughout the building. Valves. These control the flow of water into and out of the tank and regulate pressure within the system. Understand the required pipes, fittings and faucets needed for making pipeline connections. Identify the underground storage tank connections. Give connections according to the drawing using various pipes and fittings. Give inlet connections to the sanitary fittings using various pipes and fittings. Fix the water level controller to the OHT to maintain water level. Water level controllers are used for facilitating the operation of pumps for automatic filling of storage tanks. Lever sensors provided at predetermined high and low levels within water tanks dictate the starting and stopping of pumps in the absence of water in the tank. Fix the water hammer arrestor to protect the water hammer. A water hammer arrestor is a device that absorbs shock when water flowing in a piping system suddenly stops. It is installed on the supply lines of water-using appliances such as washing machines and dishwashers. Fix the pump set to the sump for pumping water to the overhead tank. Fix a non-return valve, float valve and a ball valve to the sump. Provide an air vent and an inspection opening for both the OHT and the sump. Understanding pressurized water distribution system as per the drawing. The water sump. This is a large water-tight container typically located underground, usually in the basement or crawl space. It acts as a reservoir to store water for your home. The pressure tank. This tank is usually placed near the water sump and connects to the home's main water line. It is partially filled with water and air, and the air acts like a cushion, maintaining pressure within the tank and pushing water out when needed. The pressure switch. This electronic device monitors the pressure inside the tank. When the pressure falls below a preset level indicating water usage, the pressure switch activates the pump. Check valve. This one-way valve allows water to flow from the pump or city water line into the pressure tank but prevents backflow. Let us understand how pressure distribution works. When you open a faucet or appliance requiring water, the pressure in the tank drops. The pressure switch detects this drop and turns on the pump. The pump fills the pressure tank with water, compressing the air inside. The compressed air pushes water out of the tank and into your home's pipes, maintaining consistent pressure throughout the system. Once the pressure reaches the preset level, the pressure switch turns off the pump. In this video, we have discussed fixing elbows with the GI pipe, fixing the union with the GI pipe, fixing valves with the GI pipe, assembling the GI pipe with standard fittings, understanding the water supply system from the source to the overhead tank, and understanding the pressurized water distribution system. Hope you have a clear understanding of this. Thank you all and see you in the next video.
अरे गीता, तुम मेरे घर आई ये तो बहुत अच्छी बात है। वास्तव में मुझे इंटरनेट के बारे में कई महत्वपूर्ण बातों को समझने में तुम्हारी मदद की जरूरत है।
जरूर चाचा, मैं यहाँ आपकी मदद और मार्गदर्शन के लिए आई हूँ।
देखो गीता,